There are other things you can also look into, other reactions of what? Metals. You can talk about when metal is exposed to air, what will happen? You can talk about the carbonate of metals. Carbonate of what? Metals. You can also talk about the nitrates of metals. Nitrates of what? Metals. These are some other things you can know about metals. When you come to when metals are exposed to air, the way they react also depends on their activity word series. Some immediately exposed will react immediately. Something like potassium, sodium, and calcium. Once they are exposed to air, they will do what? Tarnish easily. And when they tarnish easily, they first of all react with oxygen in the air to form their oxide. And their oxides locating mixture will form what? Their hydroxide. And in the presence of carbon dioxide, they will form their what? Carbonate. Potassium locating oxygen in the air will form potassium oxides. Potassium oxides locating what? Mixture will form potassium hydroxide. Potassium hydroxide in the presence of carbon dioxide will give us the carbonate. Will give us the word carbonate. Similarly, sodium can do the same. Sodium can do the same to form sodium oxide. Sodium oxide will give us sodium hydroxide, and sodium hydroxide with carbon dioxide will give us sodium carbonate. Calcium can also do a similar thing. These are when metals are exposed to air. Others, apart from iron, when exposed to air, will form the oxide, but the reaction will not continue. We say that it forms a protective word coating. Others, when exposed to air, will form oxide, but the reaction will not do what? Continue. We say it forms a protective coating. Then we can also look at when the metals are being heated in what? Air, they will form their what? Oxide. When metals are heated in what? Air, it forms their what? Oxide. Some very reactive metals can be heated in excess air. They will form peroxide or superoxide. When sodium is heated in limited supply of what? Air, it will form sodium oxide. But when sodium is heated in excess supply of air, it will form sodium peroxide. It will form sodium peroxide. When potassium is heated in excess supply of air, it will form superoxide of potassium. Superoxide of what? Potassium. Superoxide of what? Potassium. If iron is heated in air, if iron is heated in what? Air, it forms iron oxide. It forms what? Iron oxide. When zinc is heated in air, it forms what? Zinc oxide. So you see that most metals, when heated in air, will be oxidized to form their oxide. That is how the reaction of metals can do. It was that. I also talk about the carbonates of metals. We also talk about the word carbonates of what? Metals. When you talk about the carbonate of potassium and the word sodium, the carbonate of group 1, are stable to heat. They do not decompose on heating. If you have potassium carbonate and you heat it, it will not decompose on heating. If you have sodium carbonate, it will not decompose on heating. But other carbonates of metal will decompose to give carbon 4 oxide. If I have calcium carbonate 4 and I heat it, I have calcium oxide and the carbon 4 oxide. Aluminum carbonate 4 and gold carbonate 4 do not exist. Aluminum carbonate 4 and gold carbonate 4 do not exist. So you see how or the nature of carbonate of metals towards heating. We also have that those carbonates of group 1 and group 2 are also soluble in water. And carbonate of metals also react with acid to give salt, to give water, as well as liberating what? Carbon 4 oxide. If I have sodium carbonate 4 and it reacts with what? Acid, it's going to give us carbon 4 oxide. It's going to give us salt. It's going to give us water. And it's going to give us what? Carbon 4 oxide. Okay? So you see, whenever a carbonate of metal will react with acid, will react with what? Acid. It's going to give us salt, it's going to give us water, and carbon 4 oxide will be what? Liberated. Okay? So these are the things you can understand about carbonate of what? Metals. You can also have nitrates of metals. You can also have nitrates of metals. All the nitrates of metals are soluble in water. All the nitrates of metals are soluble in water. All the nitrates of metals are soluble in water. Which means if I have silver nitrate 5, it can be what? Aqueous. If I have lead 2 nitrate 5, it can be what? Aqueous. And that property helps insoluble salt to be formed from nitrate salt. If I want to form silver chloride, which is insoluble salt, I can use a solution of silver nitrate 5. Working with a soluble chloride is going to precipitate out silver chloride and sodium nitrate 5. You see that nitrate salt can be used to produce by double decomposition to give us insoluble salt. There are other effects of heat on nitrate salt. Some will decompose with difficulty, to give us diazonitrate 3 and oxygen. Some will decompose to give us nitrogen 4 oxide and oxide. And some will also decompose to give us metal, nitrogen 4 oxide and what? Oxygen. Let's look at effect of heat on nitrate salt. The nitrate salt of group 1, potassium and sodium, when it heats strongly, will decompose with difficulty to give us diazonitrate 3 and the what? Oxygen. From copper down, we decompose to give us oxide, nitrogen 4 oxide and what? Oxygen. The noble gold or silver, the silver triazole or mercury, will decompose to give us the metal. So these are the effects of heat on triazonitrate 5. You see that some, like the group 1, we take a lot of heat to decompose them to give the diazonitrate 3 and the what? Oxygen. Something like from calcium. If I have calcium triazonitrate 5 and I heat it strongly, it will give me what? Oxide of calcium. It will give me nitrogen 4 oxide and the what? Oxygen, from calcium to copper. But mercury triazonitrate 5, silver and so on will decompose to give the metal, nitrogen 4 oxide and what? Oxygen. These are the things we can look at that. And finally, so that we can round up the general properties of metals, we talk about what? Alloy. You talk about what? Alloy. So, what's an alloy? I said it is a substance prepared by mixing 2 or more elements to a parent metal or to a base metal to obtain a desirable product. The added elements may be carbon, it may be other metals. From the definition, if I get something like iron, which rusts easily, I may decide to add carbon to it to form what? Steel. And that steel will not rust easily. It has given it a desirable property. If I also add chromium and nickel to it, it will give me what? A stainless steel. So you see that alloy, something like brass, has a component of copper and the what? Zinc. Something like bronze has a component of what? Copper and the what? Tin. These are alloy. You have duralumin, which has manganese, magnesium, aluminum, and so on, that gives a desirable property like lightness and strength that makes it to be used in construction of what? Lead. Alloy has gone a long way in science.